Hi, my name is Laura and today I'm going to talk about my lab report. Let's look at the prior knowledge first. So Newton's second law states that if the net force is applied to an object, the speed of the object will change as its direction or speed will change. Second, in the third Newton's law, when two particles interact, the force of one particle is equal and opposite to the force that interacts on the other particle. We have the velocity and acceleration equation that we'll be using in the video. Also, the video has 240 frames per second and the mass of the car is 275 grams. Now looking at the table of quantities, we could notice that the net force are independent, the time is independent, mass is controlled, and acceleration is dependent to the net forces, and we will be proving that in the video. As we saw in the table of quantities, the forces affecting the accelerations are the net forces. This means that based on the quick observations, the car acceleration might be dependent on the net forces applied on it. We should take in mind that the friction is frictionless. This means the friction is zero. Based on the list of quantities, we'll be solving the question, how does acceleration depend on net forces? My hypothesis is that acceleration depends on net forces because when we apply force to an object, the velocity changes due to which acceleration is produced. In addition, according to Newton's second law, we know that at constant mass, force is directly proportional to acceleration. So if we apply more force, the acceleration will be more. The procedures are: we will first look at the 4 videos and take data for the initial velocity, time while the fan is running, time while the fan is off, distance, final velocity, acceleration, and after that we will analyze and compare the data using a graph, and finally we will look for conclusions. This is a free body diagram that shows all the forces. Let's look at the first video. Now let's look at the second video. Now video number 3. Finally, video 4. Here we record the data from the video and we can see the forces increases as video pass, and we can see the accelerations also increases as video pass and time is less. So let's look at this graph that will describe us better the comparison between the different forces. So we can clearly see how as forces increase, acceleration also increases and time decreases. It is important to mention that it's taken into account that random errors can occur due to the difficulty of obtaining exact values in the video, which can generate a slightly variation in the data. On the other hand, although systematic errors may appear, a review was made to limit them. Based on the hypothesis made after having collected data and after analyze and compare them with the graph 2 and 3, we can conclude the acceleration depends on net forces since, as we observe in graph 2 and 3, as net forces increase, the acceleration of the car also increases, therefore the time of travel of the same distance is less. Now let's look at the extension application of the findings. So as we can see in the last line, these are the findings of the car with a toy on it. Now let's apply the findings and let's find the mass of the toy. So let's look at the video. After watching the video and collecting the data, we can use this formula to solve for the mass of the toy. Thank you so much for listening.